What's going on, guys? Let's do this problem right here. The question here is, so there's a person works right here. So this person is working, and when he will hear the sound from both of these oscillators, and when he will not listen any sound at all. So that's the question. And this is a coherent source. What does that mean is like the frequency that creates from these two oscillators are going to be same, and also the phase difference is going to be same, that these two will travel with the same phase difference. So that's what it is meaning, and we have to find the distance at where he will listen the sound and distance at where he will not listen the sound. So let's see how we can find it. So first of all, we can create an equation for that. So let's say x distance is going to be equal to this distance, a distance minus x. Here x distance means the wavelength, and then here this is the one we have to find, x. So this is the one we are going to have. So let's create the situation. So first of all, we have to create the situation that he's going to listen not any sounds. We call this destructive interference. At that time he will not listen any sound. So let's create that equation. So first of all, we have to know this a. So we have this 2 meter right here. We have x. So a is going to be equal to square root of. So we are going to use the Pythagorean theorem. 2 square. So that's 4 plus x square. So 4 plus x square is this distance. So I can rewrite this one as square root of 4 plus x square minus x, and if x, so we have two situations, then no sound situation, that is called destructive interference. So this is if x distance is equal to 4 plus x square minus x, that is equal to half lambda. Like when we have shift by 5 by 2, the amplitude will be 0 and there will be no amplitude, so he will not hear any sounds. That's why this is half lambda, 3 by 2 lambda, and 5 by 2 lambda. So if we equate this one to this one, we can find out the distance where he will hear no sound. And to find whether he will, in which situation he will hear sound, we can find this one. Actually, the sound is going to be double in this distance, because we are going to take the situation that's 4 plus x square minus x is equal to lambda. Lambda means since both are interfering, the one wave of length is both are interfering, the amplitude is going to be double. So when these two waves meet each other and the distance is lambda, it means one wave is going to be exactly the other the wavelengths are going to be double. It's going to meet each other, and this is going to be double, right? So that's what it means. So the noise is going to be double too. So that's what we can find by equating this one to lambda and 2 lambda, 3 lambda. So this is called destructive interference, and this is called constructive interference. So we have two situations. Let's find out these two. So to find this, first of all, we have to know the lambda. So we can say velocity of the sound, that is equal to 344 meter per second. So from this information we can find the lambda. V is equal to f lambda. They have provided the frequency, so we can find the lambda. Lambda is going to be equal to V over f. So V 344 divided by 688, 1 over 2, that's equal to 0.5 meter. So we have the lambda right now. So we can equate this one and find both situations. So let's do the situation where he will hear no sound. So let's say this is the first question. So lambda, so we know the 0.5 is the lambda. Let's bring this equation right here. Square root of 4 plus x square minus x is equal to lambda by 2. Lambda by 2 means 0.5 by 2. So let's simplify this one. This is equal to 0.25, and then I can bring this x to the other side. So we have 4 plus x square is equal to 0.25 plus x, and if I square both sides I will get 4 plus x square. So let's rearrange this in this way. X square, and this is going to be double these two variables. That's going to be 0.5x, right? 0.5x, then this square 0.25 square, that's going to be 0.0625, and if we rearrange, we can cancel these here 2x's, and then if we rearrange this one and find the x value, so 8 is equal to, because this is 1 over 2 multiple, yeah, if I multiply everything by 2, 8 is equal to x plus 0.125, then x is equal to 7.875. So we have the x, this is the location he will hear no sound at all, because we found this one for lambda by 2, right? This is lambda by 2. So this means that that time the amplitude is 0, so he will hear no sound. So let's calculate the location where he will hear the double the sound. So that's the lambda location. So if we equate, and also this is 3 by 2 lambda, like for example, if you pick up the value, so we picked up 0.5 by 2. If you pick up 0.5 times 3, that is 1.5 by 2. Let's say 0.75. At the time also he will hear no sound. And 5, this is 5 lambda by 2, right? 5 lambda by 2. Also at that time he will hear no sound. So it goes on and on and on, like 7 by 2, 9 by 2, always it's going to be like that. And then let's do further this situation right here. So this is also going so on, and like 4 lambda, 5 lambda, all the way right here. So here we have 4 plus x square minus x is equal to lambda. We know that lambda is equal to 0.5. 0.5, so we can equate 4 plus x square is equal to 0.5 plus x. Then if I square both sides, we get 4 plus x square. This is going to be x square, double this one, so this is going to be double 1x, right? 1x. Then 0.5 square, that's going to be 0.25. X square cancels. Then I can simply subtract this one, so the x is going to be equal to 3.75 meters. So these are in meters. So this is the location. This person is going to hear the sound, that's going to be double the sound, right? So that's how we calculate. I hope you guys like this video. See you next time.